Hey guys, sorry I'm late. So uh, today we are going to be we're gonna start looking into week 14 material, which is gonna be due exactly 1 week from now. So uh, today we're going to begin the sections of week 14, which is inheritance. So one thing that I like about inheritance is that it allows you to create new classes from classes that already exist. And by doing that, uh, it saves the amount of work that needs to be done in order to write more complicated classes. So, uh, so here's what our agenda is today. We're going to take this meeting to do as many sections as we can uh, between sections 14.1 to 14.8. And then whatever we don't finish in during our meeting, you guys will just do over the weekend. Okay. Right, so let's start by looking into 14.1. Okay, so 14.1 says derived classes. So derived class concept. Commonly, one class is similar to another class, but with some additions or variations. For example, a store inventory system might use a class called generic item that has item name and item quantity data members, right? So so you have this class called item name and item quantity. So item name would probably be a string, item quantity would probably be an int, and then we have setter functions and we have a print function as well, right? But for produce, like fruits and vegetables, a produce item class with data members, item quantity, item name quantity, item quantity, and expiration date may be desired. So, so imagine we have a we already wrote this class. Let's say that we already wrote this class, right? But we want to write another class called produce item, and it has almost the exact same items that generic item has, right? Like if you look closely in here, the items that are shared in common is the ones in black, but the new ones are in purple, right? So one thing that you can do with inheritance is that instead of writing that exact same code again, you can have the class produce item inherit from generic item so that it contains everything that generic item contains, right? But of course, if you do that, the items that aren't shared, you're going to have to write yourself, okay? So I'm going to start this participation activity here. So generic item has these three data members. You already know that. A produce item is very similar, but produce item needs an expiration date member. Produce item needs the same data member functions as generic item plus functions to get and set expiration date. So this is new and these two are new, okay? If produce item is implemented as an independent class, all the function and data members from generic item must be copied into produce item, creating lots of duplicate code. That's actually the problem that inheritance solves, right? If produce item was implemented as a derived class, produce item need only implement what's different between generic item and produce item. Okay. So let's answer these questions here. Creating an independent class that has the same members as an existing class creates duplicate code. What do we think? True or false? Well, it just told us the answer is true, right? Creating a derived class is generally less work than creating an independent class. What do you guys think about this? True or false?
True.
Yep, true. It's also true because if you were doing this as a derived class, you only need to write these members. But if it's an independent class, you have to write everything again, right? Okay. Now, here's the part where it starts talking about inheritance, right? So a derived class or subclass is a class that is derived from another class called a base class, or sometimes called a superclass. Right? Any class may serve as a base class. The derived class is said to inherit the properties of the base class, a concept called inheritance. Okay? An object declared of a derived class type has access to all the public members of the derived class as well as the public members of the base class. So anyways, a derived class is declared by placing a colon after the derived class name, followed by a member access specifier like public and a base class name. So, so this is an example here. So you use the keyword class, and then you say the name of the class that's inheriting, and then you put the colon here, you put the member access specifier here, and then you put the name of the base class in which you're inheriting from. Okay. And so we have this class produce item is derived from class generic item. So over here is the base class, right? It has 1, 2, 3 public functions and 2 private members, right? Now, if you look at produce item, here's what I want you to see. This is the same as the example here. So what this is saying is that, hey, this class produce item, it's gonna inherit from generic item. So this little line of code here is what allows us, it's what allows produce item to have the exact same objects that generic item has. So everything that that generic item contains, produce item contains as well. So one way that you might want to visualize this is that the compiler copy pastes all of this and then puts it here, but behind the scenes, right? So generic item has a set name function, set quantity, print item, as well as item name, item quantity, on top of the other things that it also has, like set expiration, get expiration, expiration date. Okay. So let's look at this participation activity. So the base class generic item is derived, and derived produce item are declared. So we create a generic item called miscellaneous item, which has 2 data members and 3 member functions, right? And I already told you what they are, right? Since produce item is derived from generic item, produce item inherits generic items members and adds new members implemented in produce item. So in this line here, we created a produce item called parish item, and it contains everything that miscellaneous item has, as well as these 3 new members. Okay. So these lines of code simply initialize miscellaneous items private members, and this also specifies parish items private members. And there you go. All right. So let's answer these questions here. A class that can serve as the basis for another class is called what? think the answer to this one is base class. Let's check. It's not base class. One class. Is it derived class? A class that can serve as the basis for another class. Maybe we should try subclass. It's not it's not superclass, is it? What's the answer? Base? Well, we typed base class, but it didn't accept that. All right, base. Okay. In the figure above, how many total class members does the generic item contain? Well, we can count it here. Generic item has 1, 2, 3, 4, 5 members, right? Yep. In the figure above, how many total class members are unique to produce item? Well, if we go back up top, the ones that are unique are in purple. So expiration date, get expiration, set expiration. So it looks to me like 3 of them are unique. So I'm going to put 3 in here. Okay. Class dwelling has data members door 1, door 2, door 3. A class house is derived from dwelling and has data members wval, xval, yval, zval. How many data members does house H create? Okay. Well, house has 1, 2, 3, 4 unique members, and then it also inherits 3 members from dwelling. So I would say that the number of data members that house H has is 7, right? Okay. So looking at the chat, Valerie Moore says, I don't know if anyone said, but we just got our last homework assignment. You guys still got another homework assignment? Is that true?
Yeah, but this one's only 3 questions.
Yeah.
Okay. So, what do you guys want to do? Do you want to continue doing this section, or do you want to look at the homework? Because I know that time is scarce in these last few weeks of school.
It's due on the 20th. I think on the day of our final.
So you got 1, 2, 3. Is it midnight of the 20th?
Yeah.
Also, I got 1, 2, 3, 4. We got 4. Not counting this one, we have 4 other meetings until that homework is due. All right, man. I really thought that you guys were done with homework, but that's unfortunate. Jose Garcia says, "Can you help us make an outline to visualize what to do?" Is that what the homework involves? No? Oh. It's just to help you. Okay. Visualize what to do for what? For the homework or for this? The homework. Okay. So, yeah, I can try to. So, to see my thought process. Okay, sure. So, if we choose not to do the sections, I trust you guys will do this on your own time over the weekend. Yeah. Okay. In that case, I'm perfectly fine with looking at the homework. Could anyone post a link to it in the Blackboard or in the chat?
Oh yeah, really quick, I looked at the source link and I clicked it on the thing and it's still not there. Like your source is not coming up.
Yeah, there's still not one for me, right?
No.
Yeah, yeah, that's what I figured. I actually sent an email to them once more, letting them know. But it could be the case that
And I think
I'm sorry. Go ahead.
I think they're due today too.
They're due today.
Yeah.
That's unfortunate. Well, that's okay. It could be the case that that's for this particular section. There probably shouldn't be a soap for me, but it's all right though. Okay. So here's your homework, right? And it deals with classes and inheritance, and it's due on the 20th. Okay. So implement a class rectangle. Provide a constructor to construct a rectangle with width and height. Member functions get perimeter and get area. Okay. And a member function void resizes the rectangle by multiplying the width and height by a given factor. Well, that's not too bad. Problem 2 says implement classes person and street address. Each person has a street address. Provide display functions in each class for displaying their contents. That was not too bad either. And then problem 3 says add a derived class fill in question to the hierarchy of question class on the slides. So this one involves a class that that you got from PowerPoint slides, right? So, okay. So which problem do you guys want to look at first? Maybe I won't code anything, but I will do a flowchart like Jose Garcia asks. You want to do the third one? Okay, if we do the third one, I'm going to need to see what the question class from the slides looks like. Is there any way that you guys can relay that to me? Add a derived. Add a derived class fill in question to the hierarchy question class from the slides. Such a question is constructed with a string that contains the answer surrounded by space and space. For example, the inventor of C++ was Bjorn Stroustrup, and then this is the underscore underscore. So question would be displayed like this, but so you would have to override the set text function from the question class. Interesting. Okay. Okay, so you guys said that this was in slide 14, huh? Okay. Did you guys already write the question class or did the, no, here it is. Okay, so here's your question class. You have a default constructor. You have two setter functions, a check answer function that returns a true false. And you also have a display function, which I'm assuming outputs the contents, right? And the private variables are text and answer, right? So it looks like this class is already written for you. Let me take a moment to test this code out. Okay. I guess we'll just call you question. Create. Question. So I guess everything from here, I guess I'll just copy. So this is the header. Okay. Yeah, I kind of don't like having comments like this here. Oops. Okay. So one thing that I like to do sometimes when I'm writing classes is that I put the header and the CPP file in the same header. You probably shouldn't do that, but I do that whenever the class that I'm writing is small enough that I can have it be in one header file. So I'm just gonna take this, put it here. Why is this? Oh. So here's the constructor, set text, set answer, check answer, and display. So those are all already written for you. Okay. So this is the main.cpp that uses the question class, right? Okay. I'm gonna copy this and see how it works. Of course, if that's the case, I need to include the question.h, right? So I need to include a few things actually. So include iostream using space standard. And let's also include question.h. And question.h needs to have double quotes, right? Okay, so with that, all right. So let me try to figure out what's happening here. So we have a string called response. We see out alpha. So we create a question called question1. We set the text. So maybe I'll put this over here so we can see both at the same time. So we set text. So text of Q1 becomes who was the inventor of C++. And set the answer to say, we set answer to be Bjorn Straustrup. And then we call the display function, and the display function is over here where it says, where simply see outs the text, which we already initialized to this string here, who was the inventor of C++. And then we see out your answer, and then we get the line. And if the answer is correct, we will pass it to the check answer function, which takes our string called response, right? So response gets taken, and it checks to see if response is equal to the correct answer. If this evaluates to be true, it'll return true. If it evaluates to be false, it'll just output false. Right? So if I ran this right now, right? So it's asking me what my answer is. So if I said Bjorn Straustrup, it'll output 1, which means true, right? So I'll say Bjorn. That, and they'll say 1, right? Or true. Okay. But if I ran it again and I gave it a wrong answer, like let's say I put Bill Gates instead, it'll say false, right? Okay. All right, so that's not too bad of a class. All right. Now that I know what this is, let's go back to the homework and see what it's asking us to do. Okay.
What does it mean by a virtual keyword?
Well, what part are you looking at?
Like the last part before name your project as, where it says use virtual keyword in your implementation.
I believe virtual is a C++ key term. So if I said, yeah, virtual is a key term in C++. But I don't use virtual very often. In fact, I think this is the first time I've seen the word virtual. Did he explain what virtual does in class?
It's an inheritance thing. So if you you use the virtual keyword to define functions for a base class that you would use in classes that inherit from that class, to override the function.
Oh, it's for overriding.
Yeah, it's for overriding. Yeah.
Let me look that up real fast.
Plus, we just learned it today. It was in those slides.
It's true.
I'm sorry, what were you saying?
We just learned it in class today. It was in those slides actually.
Oh, okay. Virtual void print. So a virtual function is a member function which is declared within a base class and redefined. Okay, I understand. So if we wanted to, if so I say that if fill in question is inheriting from question class, it retrieves everything that question has, right? But fill in question also inherits a function from question called, what was it? Set text. Now, because the set text function isn't the same as a set text function that we want fill in question to have, then in that case, in the base question class, we need to add the virtual keyword in order for fill in question to be able to modify it. Because you don't want there's some times in which you don't want to contain every little thing that the base class has. Sometimes you want to modify one of the functions that you inherited, or maybe not even use it at all. Okay, so it looks like since this class has a class called base and it's calling print a virtual function, that means that the class is inheriting from is going to be different. Okay, yeah, this makes sense. So if you didn't have this virtual keyword here and you actually tried running this, what it would do is it would say show base class twice instead of print derived class and show base class, because it says this here and also says this here. Okay, that makes sense. Anyways, guys, you said you want a like an outline of what to do. Okay.
Honestly, I just wanted something to visualize it.
Okay, that's fine. There's nothing wrong with that. There's absolutely nothing wrong with that. So let's try it like this. I'm gonna try to make a similar diagram that we saw in the Zybooks, right? So maybe I'll say so we have actually, I'll put this on my other monitor. So we have a class called question, right? It contains two private variables called text and answer. So maybe I'll say your text. And it contains the 5 public members called question. This is the constructor. Set text. Set answer. Check answer and display. All right. We are trying to make a brand new class called fill in question, which is almost going to be exactly the same as this, right? So instead of saying this, we'll call it fill in question. So so aside from that, we also need to do a couple things. We need to when we get the so in the original program, it simply said who was the inventor of C++, but in the fill-in question, the text would actually say the inventor of C++ was __, right? So we need to override the set text function in the question class. So I guess the very first thing you would do is that over here in set text, where it says void set text, the very first thing you should do is put the keyword virtual right in front of set text. That way, any derived classes can actually change their set text definition. Okay. Now, after you do that, this would be, I don't believe you would change anything else in the question class, and then you could actually start writing fill in question. So you could go over here when you're ready to, you can, not existing, you can create a new header file, call it fill in question.h, add it. And to help you guys see this better, I could put this here and put this here. That way you can see both of them at the same time. And here's what you would actually do. In order to inherit, obviously, this header file needs to include the header file, which contains the base class. So I'm going to say include question.h. Okay. And I suppose it doesn't hurt to have these included as well. We'll put that here. But now it's time for us to start writing the inheriting class, which is called class fill in question. Now, if you remember back in the Xi books, syntax in order for us to inherit is exactly like this. we say a member act specifier. This example used public. I think I'll just use public too. And then we'll also say the name of the base class. Okay. So over here, I'm gonna zoom in so you can see it a little better. After this colon, I will say public, and then I'll say the class question, like that. So the great thing about inheritance is that by having this here, I said that fill-in question is inheriting from question. That means that everything that question contains, fill-in question also has. So that's great. So that also means that most of the work is done for you already, right? So so far so good. I'll put this over here for now. What else does it want us to do? So I know it wants us to override the set text function. That's the reason why we put the virtual keyword there. But what else did it want us to do other than that? We also need to override check answer, so that it does not take into account different spaces or uppercase or lowercase letters. Okay. So I knew we were overriding set text. I didn't know we were overriding check answer either. If that's true, I don't just need the virtual keyword here. I also need it in front of set answer. Right, guys? Okay. So now that we have that, okay. So in this little diagram here, I guess one thing maybe I should do is I'll put, I guess I'll put a little green box around each member you want to modify, because everything is the same, right? But the only real thing that you're changing is you're rewriting the definitions of set text and check answer, because those two need to be modified to the specifications that the question tells you. Everything else, on the other hand, can remain the same. So that's pretty nice. So Jose Garcia, is this a good enough visualization for you? So I'll say
Pretty nice for me.
all right, perfect. So this
One thing I wonder is, though, do we have to more or less put all the other hierarchies or just this one?
What do you mean?
Because later on in the slides, there's a set. Basically, it's instead of a fill-in question, it's a choose question, like a choosing choice one.
Oh,
would we have
like
to
a multiple
do
choice
one like? Yeah, because it says and the hierarchy is this one. Like obviously, this we'll have to add this one. I'm just wondering if we have to also place the other ones.
So, so that's pretty cool that he has a whole hierarchy for this. So, let me ask you a question. Does multiple choice question inherit from question?
Yes.
Okay. So, if in terms of hierarchy, I guess I'll this a little up here. So, if you want a hierarchy to represent this, let me do this. Oh. So you had a base class called question. Like this. And two separate classes both inherit from question, right? One of them is called fill in question, which is the one that we're working on now. And then another one that you guys are gonna work on that Amir is planning to have you work on is also going to be multiple choice question.
Yeah, it's basically just called short for choice question, or choice question short for multiple choice.
Okay. So fill in question inherits question, and choice question inherits question. So that's pretty cool. Now, the cool thing about inheritance is that the code that you wrote for question doesn't need to be written again. You can just inherit it. So that's a good thing. But yeah, so your hierarchy looks more or less like this, right?
I think so.
Yeah. Okay, great. I know we're at time here, but let's see what else we can do. I don't think this question's too particularly difficult. So I added this. We put the virtual keywords in front of both of these. We could try to finish this question now. Maybe. I don't edit functions too often though. So this is in this example, this is the base class and this is the derived class. Both of them have functions called print. However, because the base class had the virtual keyword in front of it, we're basically saying, hey, this definition of print will override this version of print. So when we call a derived class called D, and we say print show, when we print, this one will show because this one got overwritten. We called it virtual, right? And that's why in the bottom here we see print derived class. But over here, we did not put the virtual keyword for show over here. That means this new definition did not overwrite this, right? And that's why this is showing instead of this, and that's why it says show base class. Okay, so this isn't really too bad of a question. I'll put you over here again. So once again, you're going to I guess what you need to do is well, you don't need to say the prototypes again, right? So because the prototypes are already in here and it's inherited. So, but you do need to say the function definitions. So here's what I think we're gonna do. I think we're gonna take this. I'm gonna copy this, put it here. And I'm gonna copy this as well, put it here. I'm gonna get rid of the semicolon and put squiggly brackets. Same here, get rid of the semicolon, put squiggly brackets. Now, another thing is that I need to indicate that these functions are members of the class fill-in question. So I'm gonna need to use the scope resolution operator. So I will take fill in question, paste it in front of here, say colon, right? Inherited member is not allowed. It doesn't like that. let's see what this is talking about. Why is inherited member not allowed? So this is a shape called, this is a class called shape, and circle inherits from shape, right? You need to declare overwritten functions as part of your class definition. So if circle has this, it also has to say these. Okay, I did not know that previously. Okay, so I actually, if that's the case, then I actually can't leave this blank. What I need to do is say the two things that I'm trying to overwrite. So maybe I'll copy this, also put it in here. Does that mean this is fixed? Yep. And I will take this and also put it in here. Yeah. Yeah. I actually didn't know that overwritten functions still need to have the prototype mentioned in the header. I actually didn't know that. So that's pretty cool that we looked at that. Let's see what else that the homework's trying to tell us to do. So we need, okay, so I think what you have to do is when if you're using fill in question, you have to say the inventor of C++ was and then underscore, right? I think the way that you're gonna overwrite set text is that maybe I'll put this in comments so you guys can try this exercise yourself, and then we can meet again in the next meeting. So if the text was if question was the inventor of C++ was that. This function has to change it so that the question text is actually was and then underscore, right? I believe that's the way that you're going to modify this set text, right? So change to and then as for set answer, there's a couple things. So actually, let's finish talking about this first. So this is actually the only thing that you need to change, right? So that's not too bad. If you guys gave this a chance to over the weekend, do you guys think you can write the definition of this function by the time that we meet again on Tuesday? Yeah, no, likely. Okay, that's what I want to hear. Okay, now, so you have this. Let's see what else needs to be changed. We're also changing set answer, right? So set answer says, or excuse me, check answer. Oh, pardon me, guys. I actually got the wrong function. It's not set answer that we're modifying, it's check answer. So I'm going to delete this virtual keyword here. Sorry about that. I didn't see that. It's an honest mistake. So I'll actually put the virtual keyword over here on check answer. And I will take this function prototype for check answer.
Wait, so is set text still virtual too?
Set text is still virtual because that's one of the ones
Okay.
we're changing. But we're not changing check answer. We're not changing set answer. We're changing check answer. My bad. Okay. So why is this? Oh, because I called this a void when it's actually a bool. That's why. This needs to be bool. This needs to be bool. Okay. Does that fix those errors? Check answers a bool. Why are you still in there? Member function.
Is it because you're using string response instead of string question text? It's a parameter, I think.
You still have a semicolon on your
Oh,
over there, the class as well.
thanks. So what else needs to be different? So check answer uses a string response, right? So this is not an error, but oh wait, now it went away. I guess it took a while for the compiler to detect that. All right, so now it's fine. Okay. All right. So did everybody get that? You're not modifying set answer, you're modifying check answer. So I had to change this around a little bit. So this is what the header for question should look like. You put virtual here and virtual here. And so far, this is what your fill-in question.h should look like. Well, all this.
Oh, are you choosing to define everything, to implement everything in the header file?
Yeah.
Okay.
If you want me
Because I
to.
know for one of the questions, he tells us not to do that.
Oh, really?
Yeah,
Okay.
and I think question 2, he tells us to have separate header files for the header and the
For the prototypes
the
and
class
the
itself.
right?
Yeah.
All right. Well, yeah, that actually is good programming practice. To keep them separate. And the reasoning behind that is because what if your class has hundreds or thousands of different members, right? You don't want them. You don't want them in the same file because it's big. You want the header file separate so that you can just skim through it and see, hey, what does this class contain? And then with that, you can just put all of the definitions into a separate CPP file. And that's why he's telling you to do that. But for me, if the class is short enough, I'll just put them in the same header file. But if you guys want me to, in the next meeting, I'll fix this so that we are separate. Since that's the way you guys
Sure.
been doing it. Okay. I'll remember to do that before our next meeting. So anyways, you have this. You have this definition here. And now let's see what check answer is asking us to do. So check answer says we will override it so that it will take into account different spaces or uppercase and lowercase letters. So if you said Bjorn's Straustrup with lowercase letters, it should match Bjorn's Straustrup here. Okay, that actually isn't bad either. There's actually there's a lot of programming languages that have a to lower function that converts a string into its lowercase variants. So one thing that you could do is take the lowercase version of the user input and the lowercase version of the correct answer, and then compare those two. And then if they're correct, you'll return true. But if it's not correct, return false. Right? So let me look up.
What about spaces? Is there anything for that?
Yeah,
Like
there
white
actually
space?
there actually is something for that too.
Hmm.
Well, I know that there is in other languages that I write in. I don't do it in C++ too often, so let me try to look this up. C++, is there a to lower function?
Oh yeah, there's a 2 lower and 2 upper in C++. It was in the side books.
Oh, there was, huh?
Yeah. There's a 2 lower and a 2 upper. I just
Oh.
don't know about the space. Yeah, there's
Oh, so
yeah, right there. Is upper is there
you
too.
have to include a
two.
library called locale, really?
Huh.
I've never seen that, but I guess it's a thing. Okay, so if you did that, wait, does to lower only convert characters? Oh, it only converts characters. That's why it has a for loop that iterates through the entire length of the string. Well, I guess you can use that if you had no other choice, but I wonder if there's a to lower for strings. This uses transform. I've never used that. If you really hate to lower, here's a. So this one actually converts it to its lowercase form using ASCII. That's a little advanced for you guys. I don't want to make you do that. So, is there a to lower function for string? That would be really, really good if there was. So you have to use, so you would need to, you have to use transform. So if you have a string, so this main program has a string called SU and sets to this. You use transform. You say the string dot begin, string dot end, string dot begin, then the scope resolution operator, and then to upper or to lower in order to change everything from to uppercase or lowercase. So if you use this, it would uppercase the entire string. But if you use this, it would lowercase the entire string. Interesting.
Wait, what library is that in?
I don't think that. Hold on. Let me try something. Is transform already in this? Let me try something. Now, don't actually write this. I'm just doing this as an experiment. Trans. Okay, let me do this. Yeah, I was afraid of this. So the moment I looked at this, I told myself, is this a Linux exclusive library? And the moment I put it in, I realized, yep, it is. So Microsoft Visual Studio actually can't access this library. That sucks.
How can you tell it's Linux exclusive?
It's just that I actually tried using it before in a previous project, and I told myself, how come this library is not working? And I looked it up, and it says, oh, only Linux, Linux C++ compilers only have access to this sort of, because I recognize it before. That's how I know. Man, that sucks. If that's the case, is there a different way that we can? Is there a different way that we can make a string lowercase instead of using the transform function?
I mean, it probably wouldn't be too hard to write a helper function that does it for us.
Yeah, if you see uppercase A, change it to lowercase a, but that seems a little cumbersome. I wonder if locale is good with Microsoft. Locale. Yeah. Okay, so Visual Studio can use locale, so which means that means I can use 2 lower. But if I did use 2 lower, I would have to have a for loop that I would have to have 2 separate for loops that converts the correct answer and the user's answer and make it lowercase, and then I can compare the two, right? So maybe I'll put a comment from me. Include locale and use 2 lower function to make it accept uppercase / lower. So I'll put that there. Oh, Logan James Ashwell says what the for loop wait isn't too bad because we can take care of hanging spaces in the same way. Oh yeah, I guess that's true, huh? So what else? Valerie Moore says I have to go. My computer's dying. Have a nice weekend. All right, thank you. Thanks for coming, you two. Yeah, that's actually not a bad idea to have the for loop take care of hanging spaces. So let me see what else. Let me find the homework again. Where did I put you, huh? No, it's not this. Oops. Here it is. So we found a way, we found a method to convert to do the uppercase, lowercase thing. Just take the user answer and the correct answer, convert them to lowercase, and then compare the two. If they are equal to each other, return true. If they're false, if it's not, it return false. But there was actually another stipulation. It also needs to take into account different spaces. Now, the way that I'm interpreting that and that little piece of that stipulation there is like, I think what it's trying to say is if I'm going to type the comment over here. So maybe in these comments, I'm going to say change number 1, and then over here, change number 2. So change number 2. let's say that the correct answer, if the user, if the correct answer, and this is just an example, let's say the correct answer is dog, right? But the user enters the same word, or maybe I should use an example that has 2 words in it. So maybe, here, let's do this. It said Bjarne's Strauss job, so maybe I'll use this. If the correct answer is this, but the user enters something crazy, like maybe they put 2 spaces in the beginning, they put 4 spaces in the middle, and they put 1 space there, it would take these as different answers. So maybe in the for loop that's iterating through the string, maybe every time you see a space, you can remove it, so that this would change to this answer, but without spaces. And this would change to this answer, but also without spaces, right?
That doesn't take care of the case either.
Well, the case.
Oh, the first part's up there. Yeah.
You got so you got 2 things that you got to implement in this function, right? So you got change number 1, change number 2. Maybe make a for loop that iterates through both strings and removes the spaces, and then have a separate for loop that takes all the uppercase letters and then converts them to lowercase. So that's how I visualize us redefining this function. So overall, we have 2 functions that we have to redefine, right? One is set text and the other one is check answer. And set text only has this change here, where we got to put 2 underscores. At least that's the way that I'm interpreting the homework question, right? And then the other thing we got to do is change this one. And there's 2 changes we got to implement. This is the first one, where we'll make it lowercase, and there's a second one where we'll remove the spaces. And then after we do both of those, we can compare the 2. Return true if they match, false if it doesn't. Okay. Aside from that, your main.cpp has no changes. Well, actually, scratch that. It does have a change. You have to include in the main.cpp, you have to include fill in question.age. So maybe I'll include that right now. Fill in. There we go. Question.h. Question.h is exactly how it was in the PowerPoints, except there's 2 changes. We put the virtual keyword in front of set text, and we also put the virtual keyword in front of check answer. That way, the inheriting class is able to change those the definitions of those 2 functions. And these are the only 2 changes that we implemented in this question.h. Okay. Then if you go to fill in question, this is everything that we have so far. I didn't type the code for this yet, although it wouldn't be hard. So you would have to have all of this. And then the changes, here's what I'd like us to do. if you already have this, try on your own over the weekend, after you do the sections, of course, try on your own over the weekend to see if you could rewrite the definitions to do exactly what they're supposed to do. Now, this change isn't too bad. You're just adding the 2 underscores after the question, right? Like space and then 2 underscores, right? So you could use you can just concatenate the question text string, say plus equals space underscore underscore, right? This function, on the other hand, it requires a little bit of work. We're making the lowercase, we're removing the spaces, and then we'll compare the 2, return true if they're equal, false if they're not, okay? So how about everyone do their best over the weekend to try to write these definitions, and then I'll do this myself too. And then come Tuesday, after we do the lab, of course, we will try. We will compare our own individual solutions and help each other if we don't have a solution yet. Does that sound like a good plan to you guys?
Sounds like fun.
All right, awesome. All right, so we know what we're doing. We are going to do the sections. We are going to try to do this on our own. And if you weren't able to do it on your own, that's fine. I'm sure at least one of us will have a completed solution before Tuesday, right? And let me stop my share. So aside from that, is there anything else that we got to go over, or are we good for tonight? Okay, awesome. Thank you guys for coming. Have a good weekend. Bye-bye.